Hello, welcome to day 2. We're going to learn more about logarithm laws today. First, we're going to review a little bit. Log base 7 of 1/49. So that's saying 7 to which power is 1/49? 1/49 is 7 to the negative 2 power. So this answer has to be negative 2. 16 to what power is equal to 4? Well, 16 is 4 to the second power, and 4 is 4 to the first power. So we can just divide by 2 and see x is equal to 1/2. Or you can just know 16 to the 1/2 is equal to 4. Either method works. Here we have 7 to what power is equal to 7 to the negative third? Well, x just has to equal negative 3. Now, we have two important types of logarithms, natural logarithms and common logarithms. Natural logarithms are when there's no base written here. We assume that that base is 10. So what this is saying is 10 to which power is equal to 100? So our answer is going to be 2, because 10 squared is 100. Now, down here it's a little bit more complicated. Natural log of 100 is saying e to which power is equal to 100. Now, e is a specific number. It's kind of like pi in that it's a number that is irrational, so the digits keep going forever and never repeat, never terminate. And it has certain properties that make it important, especially in calculus. Now, the log key is on your calculator. That's the common logarithm, and it's the base of 10. So use your calculator and find log of 200. All right, on my calculator, I got 2.3001029996. That's a long answer. What this means is 10 to the 2.0 or 2.301, that's a 3, will be equal to 200. So this is the exponent on 10 that will get me to 200. In this case, our next one is natural log, which is ln, which seems dyslexic to most people. But that's the base of e. Now e, so we'll take e to which power is 200. Now, the natural log of 200, if you type this in your calculator, will give us the answer of 5.298, and so on and so on. It keeps going, 317167. Now, what e is e is the number 2.718281828, and it looks like it's repeating, but it doesn't repeat. It keeps going and going on forever and ever, and there's no end to it. So if I have 2 point something to a power, or 10 point something to a power, you need to raise this to a bigger power to get up to 200. So that's why this is higher than that. Alright, so determine these without a calculator. This is 10 to which power is 1,000. We can just count up the zeros. That's going to be 3. Natural log of e squared. That's saying e to which power is e squared. Well, that has to be 2. Log of 100th. That's the same thing as log of 100th. Well, that's log of 1 over 10 squared. So it's saying 10 to which power is equal 10 to the negative 2. Well, that answer is just going to be negative 2. Now, natural log, remember this is e. E to which power is 1 over e to the third. Well, it looks like that would be negative 3, because e to the negative 3 would be 1 over e to the third. Now try this one on your own. Log of 1/10,000th. Well, 1/10,000th is 1 over 10 to the fourth. So 10 to which power is 1 over 10 to the fourth? Negative 4. Natural log of the square root of e. E to which power is equal to, this is the same thing as e to the 1/2. So that's just saying x has to be 1/2. Now convince yourself of the following. Now, log base a of 1 has to be 0 because a to the 0 is always 1. Log base a of a to the n, a to which power is a to the n? That has to be n because a to the n is equal to a to the n. Finally, where are we at? Log base a of a to which power is a? That has to be 1 because a to the first is equal to a. Alright, now this gets a little complicated at the bottom, but the first two will show you the pattern to get the last one. The last one's the 7 to the log base 7 of 15. That gets confusing if we don't see a pattern. So 2 to log base 2 of 8. Log base 2 of 8 is 3. And then 2 to the third is 8. So same thing here. Log 100 is 2. So we're going to take 10 to the second power, which is 100. Notice when I'm taking a base to the log of the same base of anything, this number is what shows up when we're done. So notice 100 and 100. So if I take 7 to the log base 7 of 15, it doesn't matter what's happening here because the 7 and the log base 7 cancel out, leaving just a 15 left over. So a to the log base a of x is always going to be x. It doesn't matter what a is, just as long as it's in both of those positions. Or 8 to the log base 8 of 51, surprisingly, 51. E to the natural log of 6, it's saying e to which power is equal to the natural log of 6. Oh, no, it's not. It's saying this is the natural log, it has base e. So this would just be 6. Natural log of e to the negative fourth. So this is saying e to which power is equal to e to the negative fourth. So that's just going to be negative 4. Notice how e and natural log cancel each other out, just to have that exponent in there. Alright, laws of logarithms. If I am multiplying two values together within a logarithm, I can separate it and have log base a of x plus log base a of y. So if I'm multiplying, I can add. If I have log base a of x over y, I can take the log of base a of the top minus log base a of the denominator. Now this last one is a very important rule. If I have log base a of x to a power, I can take that out in front and then say b log base a of x. This is a very, very important rule. Alright, now let's start a proof of log base a of xy is equal to log base a of x plus log base a of y. So if this is true, we know a to the m is equal to x, a to the n is equal to y. So then log base a of x times y is the same thing as log base a of a to the m times a to the n. Because we know x is equal to this, y is equal to that. Now, Now from here, what we can do is we can add these two together. So we can say this is log base a of a m plus n. Now, log base a of a to the m is a to which power is a to the m plus n. That answer is just going to be m plus n. And we know m is equal to the log base a of x, n is equal to the log base a of y. So log base a of xy is equal to log base a of x plus log base a of y. Any questions with that? I don't know why I asked that. I do that every once in a while, and nobody's here to respond. All right, let's do the other one. A proof of why log base a of x over y is equal to log base a of x minus log base a of y. So, same thing, a to the m is equal to x. Over here, a to the n is equal to y. So this would be log base a. If it's x over y, that would be a to the m over a to the n. I should make my m look more like an m. Now we know this rule is the same thing as a to the m minus n. A to which power is equal to a to the m minus m? That would just be m minus n. And so, just like the previous problem, that's going to be log base a of x minus log base a of y. And my proof is complete. All right, now we're going to prove that b times log base a of x is equal to log base a of x to the b. All right, so if we have m is equal to log base a of x. Now if I write this in exponential form, I can say a to the m is equal to x. Now if I raise both of these powers to the b, so I'd have a to the m to the b power is equal to x to the b. Now this is legal to do since we're doing the same thing to both sides. We have a to the mb equals x to the b. So now what we'd have to do is take the log, or write this in log notation. So we'd say log base a of this side, which is x to the b, is equal to our exponent, mb. Now, m, we've said earlier, is log base a of x. So this would be b times log base a of x. So now I have my proof. Log base a of x to the b is the same thing as b times log base a of x. And my proof is finished. All right. So now we're going to actually use them rather than just proving them. And if I have log base 2 of 96 minus log base 2 of 3, since this has the same base, I can divide these. So it could be log base 2 of 96 over 3, which is log base 2 of 32. So that's going to be 2 times 2, which is 4, times 2, which is 8, times 2, which is 16, times 2, which is 32. So the answer is 5. Now for this situation, there's a couple ways we can do it. We can take this 2 and put it up here if we want to use our rules. We can say the log base 4 of 8 squared is equal to the log base 4 of 64. And 4 to the third power is 64, so our answer is 3. Now for adding two logs with the same base, we can combine it. So this would be log base 6 of 9 times 4. 9 times 4 is 36. So 6 to which power is 36? That answer is 2. Alright, so when we use the law of logarithms here, we can combine these two by multiplication, but we have to divide by this one. So this would be the log base 7 of 8 times 5 divided by 2. So log base 7 of 40 halves, which would be 20. Now if we have the second, we still do pretty much the same thing. It's log base 2 of 7 divided by 3 times 5. Now that times 5 is out here, so it's like times 5 over 1. So that would be 35 over 3. 35 over 3 it would be like, is it 11 and 2/3? How about we just write 35 over 3? That's all we need. Alright, now in this case we have that 2 out in front. First thing I'll do is put in the exponent. So I have log base 5 of 4 squared plus the log base 5 of 3. So that's going to be log base 5 of 16 plus log base 5 of 3. Since there's an addition, we can combine those. So it's log base 5 of 16 times 3, which I believe is 48. Yep, I'm right. Log base 5 of 48. Alright, hopefully that helped you get through, will help you get through the homework.